Hello everyone, I am Dr. M. Manikam, Assistant Professor at Department of Physics, Dr. SNS Rajalakshmi College of Arts and Science, Coimbatore. So today in this video, we will discuss about BJT, Bipolar Junction Transistor, Common Collector Configuration. So in our previous lecture series video, we have discussed about the common base configuration, common emitter configuration. So today we will discuss about common collector configuration. In common collector configuration, so it is we can known as, also we can call it as, it is the emitter follower. So we can justify the name, the emitter follower later. So the collector terminal is common to both input and output here. So for common emitter and common base means, in common emitter, emitter is the common and both the input and output. So here the collector is the common for both the input and outputs. So it is widely used for impedance matching purpose. We are utilizing common collector configuration circuits. So this is just a circuit diagram for common collector configuration. So here collector is the common for both the base and collector. This is connected in the two, one of the uh, power supply negative, and then another end is connected with the positive of the power supply VEC. So this is the circuit diagram, the configuration for common collector. The basic concepts for input applied in between the base and collector, then output is taken from the emitter and collector. So already we know that there are two PN junction diode inside the transistor, so it is working. So collector act as a common reference terminal. So the voltage, how the voltages are supplied in the common collector configuration is VB, that is the base emitter voltage, VEC is the emitter collector voltage. So there are two power supplies we are utilizing. So base emitter junction, that is working in the forward biased condition. Then collector collector base CB junction is working in the reverse biased condition. CB junction is working in the reverse bias junction. Okay, so this is the input characteristics for the collector, common collector configuration. So in axis we have taken, that is VBC, then y axis we have taken IB as the current. So if you are increasing the base collector voltage, so the 5 by maintaining the VEC, that is a constant one, so 3 volt or 5 for 5 volt. So it is the input characteristics come like this. So the standing lines, so if you are increasing the voltages, the current will drop suddenly. So likewise the for different voltages of emitter and collector and voltage power supply also. So the same configuration or same style of outputs will come out. So the output characteristics for common collector configuration. In x-axis we are taking VEC, that is power supply voltage in between, potential difference between emitter and collector. Then in y-axis, that is IE, then emitter current. So here the output, so output is taken from the emitter and collector. So we are using the emitter collector as a voltage is the output voltage. So in cutoff region, that is when IB voltage is IB current is 0 means the cutoff, it's working in the cutoff region. In saturated region, so it is suddenly increases for different IB currents like 20, 40, 60 up to 20, 120 microamperes. So the in active region, so all the IE currents, I mean emitter currents are the constant for while increasing the VEC voltages. So current flow in the common collector amplifier, that is base emitter junction is forward biased. Small base current controls the large emitter current. So that small base current only controls the large emitter current. So because while increasing the emitter current, the base current only, so the current IE, emitter current also increases. So the output current flows through the emitter, then current collector remains almost constant. So collector current, that is the almost constant, we can see in the diagram. Okay, so then collector current, current relationships between the in the common collector configuration is so IE, that is emitter current, that is equal to IB plus IC. So the input current value, that is base current IB, then output current value, that is IB output current, IE emitter current is the output current. So while a base is the input, so then emitter is the output. So collector is the common one. So current gain of a common collector amplifier, that is gamma, that is equal to IE by IB, which means beta plus 1. So the very high current gain, so it is when compared to other configurations, very high current gain, it's greater than CE configuration. So because so the C is the IE by IB, so we can say it is I is the current gain is the beta, here plus 1 is additionally added, so while performing the common collector amplifier. The voltage gain of CC, common collector amplification, is voltage in almost 1 unity. So output voltage follows input voltage. That's what we are called it is emitter follower. So the output voltage follows the input as it is. So if you are supplying 1 unit of current to the common collector, means that same 1 unit of almost same 1 unit of current will come out from the emitter. So it is called emitter follower. What are the applications? Means it is used to in the buffer amplifier, impedance matching circuits, audio output stages, then voltage follower circuits. We are using the common collector configurations. So what are the advantages are high input impedance, low output impedance, then no phase in inversion, then good current gain. So this is the advantages of common collector configuration. Then some disadvantage also is there. So voltage gain is less than 180. So this is the one of the disadvantage. Then it's not suitable as voltage amplifier. So this is the disadvantage of this common collector configuration. So thank you for watching this video.